this computer. There we go. All right, recording is started. All right, so we're just going over this for Janan. Everybody wave. Hi, Janan. We miss you. We're recording for you. We will try to record as much as we can. It may or may not work. You may or may not watch this. Okay, so we're just going over, hopefully it saves the chat screen over here. So let's see, polyline, spline, arc, copy, ellipse. Ooh, polar tracking. Peter, what are you doing with polar tracking?
Well, I was doing the man-made site features, so I did an outline around the art museum. And if I had done, if I hadn't used it, it wouldn't have been right angles.
Ah, okay.
So I needed to do that and then set it to the last line segment.
Getting some precision. I thought you might be like tracking polar bears or something, but no.
I wish.
Yes. First time we got in a Zoom laugh. I like it. All right, so let me see. Anybody else? Anybody find any tools that we didn't go over last week, like polar tracking or ellipse or arc? Anybody?
Oh yeah, there's this. It's like a cloud-looking one.
Ah, the bubble tool.
No, not the bubble tool. It's like under the circle and the rectangle one.
Yeah. It's all right. So the nickname for it is bubble tool, and it looks like a little cloud thing. Yes. So that's a really interesting tool. So in drawings, especially, so for example, if we were doing drawings by hand, we might like circle something in a different color, right? Like we were doing that with the monographs. We were trying to annotate them in a different color. It was easier to see. So in drafted drawings, a shape that doesn't usually show up is like those curlicue cloud-like lines. And so you would do that anytime something changes on the drawing. So let's say that like you sent drawings out to the contractor for them to look at, and then they realized that something was like incorrect, or maybe something needed to change, or you needed to update a detail, you would do that, and it's called bubbling. And so you would actually do this squiggly line around it, because most things in construction are not squiggly lines like that. And so it's called bubbling, and it basically is a visual way of saying, hey, pay attention to this. This changed, and it's updated. And it's the same way that we were doing the red lines when we were doing the monograph stuff. So, but it is a fun tool to use. I would describe it as silly, and I enjoy it. So there we go, the bubble tool, ellipse, copy. Kelly, you like good old copy. Tell us about why you love copy. Oh no, Kelly, you there?
I just thought it looked a lot more like uniform, like when because I was making a lot of like circles, like going out, kind of.
You
So
don't have
it made
to
it.
reinvent the wheel.
Yeah.
Yeah, you can use the same stuff. You got the same shapes. You like those shapes. You get to keep using those shapes. The sun has come out and it's starting to get warm in this back room here, guys. All right, so arc, polyline, hatch. Gabby, using hatch, what was that like? Is it a little, have you used AutoCAD before? Uh-oh, there she's back.
I tried to press spacebar, but it wasn't working. But yeah, I used AutoCAD before, but I really like that it has different textures in Hatch. So
Yeah.
for like the man-made nature that I wanted to do in like the art museum, like I guess like the texture kind of helped with that too.
Yep. Now, one of the things that we're going to find out about Hatch is that as you're using it, it shows up different in different scales. So it'll change dynamically. So when you print it out, you might not get what you're seeing on the screen, or when another person opens it on their screen, if they have a different resolution, they might see it differently. But we are going to see if we can use that hatch more in the future. It does some weird things, and sometimes it's incredibly frustrating, and sometimes it's kind of cool how it breaks down. Very cool. All right, so now new questions. New questions. What kind of tools were most frustrating? So what kind of tools are most frustrating, or what tools did you guys have questions about, or what do you want to learn more about that we can hopefully spend some time on today? What kind of things did you run into and it didn't work the way that you expected it to? All right, there's typing going on. Scaling the hatching, yep. Scaling hatching is definitely difficult. Oh, snap, okay. Oh, snap, we will go over oh, snap. That's 2 snaps. Okay, 2 snaps, arrows, okay, figuring out line weights, yes. All right, now I will say, Calvin, you put in figuring out line weights. we are going to work on, and Alex, so did you, we're going to actually use line weights more in Illustrator. It's not because I don't want to figure out line weights in AutoCAD. You can do them in AutoCAD as well, but they're one of those things that actually changes dynamically depending on what you're printing out at. So if you're printing out line weights, you have to actually set up a plot file for yourself. Everybody does it slightly differently, and I have found that the preview that you get for line weights in AutoCAD leaves something to be desired. And since we're oftentimes going to go through some kind of PDF output, it makes sense just to kind of move over into Illustrator, adjust the line weights there where you're looking at a white background, because as you guys have, as we talked about during the monograph, having black backgrounds or colorful backgrounds gives you a different impression of the line weights. So I find that white lines on a black background look different than the same line weight of a black line on a white background. And in Illustrator, it can change dynamically and it can do it live. So what you see is what you get. And it's a little bit less abstract. So to kind of go into how to manage line weights digitally, especially when you're doing it for the first time, we're going to do that mostly with Illustrator starting next week. All right. So it's not that I don't hear you. I absolutely do. And it's definitely a skill to pick up. But we're going to structure this just so that it's not so overwhelming. And we're going to do it in Illustrator. I'm seeing some nods from some people that have been there. Okay, we will definitely go over OSnap because all of you guys are talking about the OSnap tool. There's different ways to line it up. There's different ways to deal with it. And remembering to turn it on and off, because it's a very powerful tool, but it's also very frustrating. It's like super glue. It's a really powerful glue, but if you're not careful, you end up sticking to absolutely everything, and that's not helpful. Cool stuff. All right, the first thing that we're gonna do, I wanna share my screen, and I just wanna go into the first issue that we had today, which was naming and file management. So let's go over to here, and what I wanna say is, Seema, can you tell us a little bit about what happened earlier today? It's not to embarrass you, it's because it's actually a really common thing to do.
So I think what I did was I clicked on it without downloading it, and I just went and I opened it straight with AutoCAD, and I just started working on it. And then when I saved it, I thought I saved it into my personal file, but it just kept saving to the original.
Yeah.
So when someone else tried to open it, they were like, "This is not the work. This is your work."
Yes, exactly. So,
And,
all right. So I'm glad we have GroupMe so that we could start dealing with that issue immediately. Did anybody else encounter this issue with the file? It's a really common thing to do. Yeah, Peter, I know you did. So it's a really common issue with the file. So here's the best practice that we want to do. What you want to do is you want to make sure that you're downloading the file, and as soon as you open it up, you want to save it with today's date and your name. Always, no matter what you do, the first thing you want to do is make sure that you're saving a copy of the file locally. And this is also important for your own work. So let's say you're opening up something that you worked on yesterday. The very first thing that you guys want to do is save it with today's date and today's information. You guys worked on a file for class today and you were working on it about an hour ago. What you want to do, if you have that file open right now, you want to save it, and you want to save it as like part 2 or afternoon or like PM file. You want to put something on there right now. So let's take a moment right now. If you need to have your AutoCAD open, have your homework file open, and let's do a save as, and make sure that it's designated with its own unique number. That way, what you did for homework is backed up and you're not going to write over top of it. That's absolutely essential. So one way to protect yourself against doing this, right? So Seema, if you had immediately saved as, it would have saved locally. But also, if by accident you were uploading it, it wouldn't rewrite over the old file. And that's the other reason to do it. Now, what happened is that I'm actually able to like dial back. And so I saw that it got deleted and rewritten and deleted and rewritten. And so I went back and I refreshed the folder to about 2 hours previous, but it still had the new Seema old file in there. So it just refreshed that Seema file. So what I ended up doing was renaming it so that we knew what it was. And then I loaded from my catalog the old Rome drawing itself up in here, but I renamed it Andrew's fixed file so that you guys would know what it is. And part of the reason why I put it there was because I knew with my name on it, it would be at the top of your list. Sometimes I will rename them with like a AAA and a space so that you guys can have them there. This is one of the only times where I won't put the date on it because this is not going to be the final file. What I'm going to do is I'm going to delete Seema, I'm going to delete your file, and I will replace it with a new file now that we've all gotten squared away, all right? But in the meantime, while I'm trying to fix the situation, I don't want to delete any information. I want to make sure that we have the good and the bad information in there, make sure that they're stacked appropriately, and then move the bad data out because I don't want to miss anything. That's a really common occurrence. It happens all the time. And the only thing I'm going to ask you to do is to share when you mess up like that so we can all learn, because we learn from making mistakes. Okay. Next thing I want you guys to do, next thing I want to talk about today. So here is the infamous Rome file. This is the actual Rome file. And I want to briefly go over what we're doing, like what this file is like and how this is different from Photoshop. So we have entered into the vector territory of image making. I'm going to try to do this as quickly as possible, but basically in Photoshop, we were working in pixels. And pixels means that we're dealing with lots and lots of little squares. And I'm actually just going to use rectangle right now to draw a little square right here. And I'm going to use the array tool to just make a little, so I'm going to just use an array tool here to make lots more of these little squares. And I'm just going to use the graphic interface of array. So pixels on a computer screen, and this is how kind of digital images and pictures and JPEG files are built. They see data like this. They're all little squares. They're exactly 1 pixel wide and 1 pixel tall. And they come in, they used to come a long time ago in 256 different colors. Now they come in thousands of colors. And an image is made up of these little pixels, and each pixel is its own color, and the gradation of those colors creates an image. What that means is that to have a really, really high resolution image, you need to have really tiny pixels across a certain limit of length and height. So for a lot of the images that we were working on for the monograph, those images were of a large enough quality where they were across maybe 10 inches or 20 inches, and they were at a DPI of maybe somewhere between 150 and 600. One of the problems that we had, and one of the reasons why we didn't want to start by sourcing images from the internet, was because those images are made to load quickly, and so they're small. So there's not a lot of DPI, and they're only a few inches wide, which means that they don't scale very well, because after a while, you just start stretching pixels, and what happens is that the pixels just get stretched by basically doing this, because you can't really add data where there isn't data. So what you end up doing is you end up getting more and more open space between the pixels, where the computer is trying to take its best guess at what it thinks the color in between those pixels should be, and you end up getting an image that is pixelated. This also means that in order to get a higher quality image, you need to get the pixels closer together and you need more of them. And we saw that in Photoshop because as we would increase the size of the image and increase the resolution in DPI, the size of the file would grow exponentially. And we experienced that quite a bit when we first introduced Photoshop, where you guys would see that we would make the image 2 times as big and it would actually increase at the square. So if we made the image twice as big, it would be 4 times larger, which means that if you take an image that's maybe 4 inches by 4 inches and increase it to be even larger, it gets really big really fast. So we got some really big file sizes. That's how pixels work. That's how what we call rastered images work. Okay, and actually in this file, I have a raster image right here. The map of Rome right here is a rastered image, or a rasterized image. It's broken down into its pixels, and as I zoom in, you can see that it starts to become pixelated. Now, what we have now in AutoCAD is what we call a vector image. And a vector image,
Hey, Andrew.
a lot simple, yeah.
My The image of the actual Spanish Steps in St. Peter's
Yeah.
is not like linked, I guess.
Okay, is it broken?
Yeah, that's what it says.
All right,
From
we can get into it a little bit more.
Okay.
So let me just finish introducing this vector thing, so before you guys all go to sleep on me. All right, so here's what I want to tell you guys about vectors. Vectors are really kind of dumb in the way that they're laid out. What we're basically looking at right now, we're not looking at pixels. What we're looking at is a bunch of equations. Equations in geometry that are being shown to us graphically. So you can see that as I hover with my crosshair across the desk here, it says specify first point. When I click, it specifies the first point, and then it specifies the second point. This line, everything about that line exists as 2 points that there's an equation that identifies the insertion point and the termination point, so the start and the finish, the fact that those 2 points are connected, and the qualities that that connection has. So for that connection, we can give it, a color by putting it on a layer, and that layer has certain attributes, but it basically just says, hey, the attribute between these 2 points is this layer. So it doesn't actually even save the information of those attributes onto that line. It just says, please reference this file over here. So what it means is that instead of viewing this image as a bunch of little tiny dots of information, this is actually selected as numbers of objects. And so right now we have a drawing with several thousand objects, but we've been working in files which are mapping out probably tens of thousands, if not hundreds of thousands of pixels. So 1,000 objects that have a defined start and finish is actually a much more simple file. And so if you guys look at, if I put in the photograph of Rome that I used for this that I was chopping out, that photograph of Rome is a map that's probably, I'm trying to see, I have a miniature copy of it in my room right here, but the actual copy is like 20 feet wide by 20 feet tall. So that would be several gigabytes worth of image information. It covers the same amount of space that we have right here. The file with the green lines that we're looking at right now is approximately 750 kilobytes of information. And just to put that in perspective, the size of my image on your computer right now with my face in it is larger than 750 kilobytes. It's probably on the order of like 1.5 megabytes. So what that means is that we can pack a lot of information that's really accurate in a very small file size. And as I zoom in right here, I want you guys to see that as the image quality kind of gets worse and worse on the map, the vectors stay exactly the same. They don't get bigger, they don't get smaller, they don't get thicker or thinner, they just stay exactly the same because they have no substance. They're just equations. The power of this is that we can put a lot of complex data in a very accurate way all together in a very small file size. The other thing that we can do about it is that we can scale it up or down. And so if you're not in CABE, if you were in DEC and you were doing graphic designs, oftentimes signage or advertisements are done in vector graphics, which enables a designer to make a design that's, about this big on their desktop, and it can be extruded and expanded to fit and wrap around to be an advertisement that wraps around an entire septibus. And if you go up to a septibus that has one of those wrapped advertisements on it, you'll see that those images aren't pixelated because they are vector graphics, which means that it's just a line with an embedded quality basically baked into the DNA of what that line is. Whereas if you had a rasterized image, and this happens all the time, like insert your favorite pizza place menu here. If you look at the pizza menu, I am gonna bet you that some of the images look really, really pixelated because they're probably just cut and paste in cheesy Photoshop. So the reason why we use vector graphics is because of the accuracy, because of the size, and because they can be scaled and used and reused at a variety of different in a variety of different ways by different programs a lot faster. It also means that for the next stage of our project, which is going to be massively collaborative, which means that everybody is going to have a piece of how they collaborate with the project, for the next part of the project, if we were gonna do a Photoshop file that we all did together, where all of you guys submitted your own layers, that thing would be easily 20 gigabytes and nobody's computer could open it. But for our project, I'm gonna just give you guys, here's the example project from 2 years ago. So this is the file from 2 years ago where we are mapping out a dining room, not a, we're mapping out a diner, not a urban space, but this is a kind of miniature urban space. I don't even have all of the, I'm gonna just bring up the layers here so you guys can see. So we have literally hundreds of layers in this file, hundreds of layers in this file. And the file size is actually not that much bigger than the row map. It's just a little bit larger because as we add attributes to the lines, it's not increasing its complexity. You can even see that this geometry is really, really complicated, but it's also not that complicated because it's just lines with insertion points and inflection points on the splines. It's just circles with radii or blocks or rectangles. And so it's actually getting a lot of complexity out of relatively simple geometry. And that's the other thing that's important to understand here as we go into our discussion this afternoon. One of our challenges is to kind of create complexity through density, but not necessarily by making quote unquote crazy shapes. Our objective is to try to find, and I believe Ivano was saying this yesterday when he was giving us feedback on in studio, which is clarity, content, and context. And then over the weekend, all of you are going to edit from this down into something that is a little bit more clear, okay? So that's just kind of an introduction to like what a vector is, how we use it, why we use it that way. And what I'm gonna try to do now, so what I've asked you guys to do for today was to make a delightful mess, all right? I have my list over here of all of the pieces that you guys were gonna track. So I've got that list right here of all of the different things that you guys were tracking. So Janan, for example, was tracking pedestrian traffic, thresholds, and infrastructure. So what we're gonna do is we're going to discuss what makes for good diagrams and also which diagrammatic elements, which lines are really good partners for other lines. So that's a little bit of the conversation that we're gonna have. We're gonna use that conversation to decide what are the best practices, what are the best ideas that we've been having? Like who should we be looking at? What kind of examples? What have you guys discovered? What makes for clear things what makes for clarity in a diagram? So for example, one of the things this morning's class figured out was that everybody seems to draw trees on a green layer as circles. And in the words of one of my students this morning, one of your classmates, trees are not really circles, so we shouldn't draw them that way. That's a best practice from this morning. Here's kind of a higher order of a best practice, which is it's a challenge, but it's important to quote, draw where people actually are and not our idealization of where we think they are going to be, unquote. I thought that was a really good perceptive notice. So one of the things that I want you guys to be doing as we're looking at each other's drawings is to think about what is it that is really working well about this drawing. Maybe it's a certain type of line, maybe it's a collection of lines, or maybe it's actually a sampling and an interaction of lines between different people in the group that you're in. That's number one. Number two, I want you to think about, ooh, that's a good idea. I want to steal it. So that's the second thing to be looking for. What is it that you want to steal? What do you want to see that's such a good idea that you want to snag that and you want to draw stuff that looks more like that? And the third thing that I want you guys to be looking at today, the third thing is, what are we missing? All right. For everybody, right, for your homework, you were tracking at least three different elements across the site. And then also you were bringing a fourth, right? Like your own special ingredient, your own special observation that you were bringing to the diagram. So for example, somebody this morning decided that they were going to track good noise versus bad noise. So horn honking versus birds chirping, all right? We weren't really sure where chickens fit into that, because some people thought it was good and some people thought it was bad. but kind of bringing in your own tweak. So the third thing is, what are we missing? What do other people need to be bringing? And it might be something that all of us are missing that we only see after we tour around to everybody's boards. Okay, that's where we are today. Now, in order to make this recording work for Janan, here's what we're going to need to do. We are going to take a 1 minute, we're going to try to make this work. We're going to take a 1 minute break because I need to actually end the meeting so that the recording can start to compile itself. And then I'm going to, so what we're going to do right now is we're going to end the meeting. So I'm going to stop the recording right now. And in 1 minute, you guys are going to log back on to the room and we're going to start meeting again. Okay. So I'm going to stop my sharing. I'm going to